Hello everyone, this is Ian. In this video, we're going to talk about the Random Axis Extrude operator, which is a recently added operator in the Random Flow plugin. So what this does is it randomly selects faces that are facing the X and Y axis, and then tries to extrude them. So that's why it's named Random Axis Extrude. We have here the X, Y, and Z axis, and these rows represent this axis. As you can see here, it's the UI is neatly arranged just to mirror this the XYZ pattern. So it's kind of confusing at first, but actually the documentation explains a lot on how the script how the operator operates in the script level. So all you have to really take into account mostly is the properties like the source extrude, loop offset, we have the axis order, the axis loop, which determines how many extrusions can be done in each axis or XYZ axis, the loop seed, which of course randomizes the extrusion, and we have the threshold and the influence. But before we go to that, let's start with the basic randomization pattern. So if x is equals to 1, y is equals to 1, and z is equals to 1, that means those numbers represents the axis loop. So that determines how much extrusion can be done in the x, y, or z axis. So if all axes have the same number, then the standard pattern will follow the x, y, and z. That means the loop will start at the x-axis. Then after extruding all the after looping through the faces to find out which of them are facing in the x-axis and tries to extrude them, it will loop through the y-axis and then it will loop at the z-axis. If however, if we have x1, y is equals to 2 and z is equals to 1, again this is the axis loop. So we have x is equals 1, y is equals 2, and z is equals 1. So if we're using the axis order highest, that means that the axis with the highest axis loop number will come first, will be looped first. So we have y in this instance, and then since the x and z axis have the same number, then it will normalize in this in our standard pattern, which is xyz. So in xyz, x is the first one, so x and then z. If we have z is equals 2, y is equals okay, z is equals 3, y is equals 2, and x is equals 1. Then using the axis order highest, we have z, then the second lowest is y, or second highest is y, and then x. If we have z is equals 3, and y is equals 2, and x is equals 2, then since z is the highest, z will come first. And since y and x have the same number, it will normalize in this pattern, which is x, y, z. So x and y. So it's as simple as that. And that is the scheme using the axis order highest. It will not work with the lowest, using the lowest axis order method. Oh, excuse me. It will work with the, um, but in reverse. Okay, if if it will work the same way but in reverse, but if the axis, if some of the axes have the same number, it will still normalize with our standard pattern, which is the x, y, and z. Let's just mirror this x, y, and z, and then design this a bit and codify. Okay, I actually have presets here, as you can see, but let's start fresh. So let's uh, let's try and extrude from this side, which is the x axis. Try and use the 3D widget as your guide for figuring out which axis to extrude. So let's try 4 extrusions. You can see there. So 4 extrusions on the x-axis, 2 extrusions on the y-axis, or 1 extrusion in the y-axis and 2 extrusion in the z-axis. So that means that the x will come first, z second, and y last. So x, z, and y. So loop offset means that you can see here that this face is perfectly aligned to the z-axis, but this is also kind of like facing the z-axis and also facing the x-axis and also facing the z-axis. But if we want to include that in the x-axis, we have to go to the threshold. So let's say let's increase this to 1, and when we now that we've increased it to 1, you can see that we can now extrude. This can now be extruded in the x-axis. So this has a soft cap or a soft max of 1. You can also manually enter a value to go past this. But if you use values that is greater than one, then something like this face, which is exactly facing the z-axis, will be included in the let's say if you use 2 threshold on the x-axis. So somewhere between, so it's kind of so just stay somewhere equals to 1 or lower. And we have the loop offset. Okay, so loop offset. So this is 0. Loop offset means that since in this example we have 4x and y1, let's call the source mesh the stem and the extrusions the branches. Okay, so x is equals to 4, and then y is equals to 1, and z is equals to 0. So when we loop first, since x will be loop first, since this is the highest, and in the first loop, meaning when the first loop is over in the 4 loops in the x-axis, then it will go to y, and then if it will be mostly extruded here since it is 1, then z is equals to 0. Then the second loop is equals to, we have the second extrusion for the x, and since the y-axis only has 1 extrusion and it is already extruded in the first loop, then This is 0, and this is 0. So third loop, third extrusion for the x-axis, no more extrusion for the z, and it's the same thing for the fourth extrusion, and z is equals to 0. Okay, so what the loop offset does is as you increase the value of this, even at 0 it still works. You can see that it's still being extruded in this part here. So even at 0, the script allows this to work, but in essence, if you increase the value, this will try and delay the extrusion of the y-axis higher and higher. So so essentially you can delay this 0. So if it's delayed here, then this one extrusion here can have a chance of extruding in the second loop here, or in third loop here, or on the last loop. Okay, so what this does is delay the extrusion for lower numbered or lower axis loop numbered axis. So it has a chance. So this one single extrusion count can have the chance to extrude at the fourth branch of the x-axis. So let's see here. So four branches. Let's actually decrease the branch of division and see the effects of this. Okay, let's just set this back to 0.5. Sorry about that. There you go. Um, it is mostly being extruded at the first loop, and it cannot go to the second or third or fourth loop because it's already being expended. The extrusion is already being expended at the first loop. So we need to try and delay that using the offset. So 0.8. Now you can see that it extruded here, and also a part of the x-axis also extruded here. Let's try one. You can see that sometimes it doesn't extrude at all because unfortunately the script didn't meet any of the uh, conditions to have an extrusion, so you have to really go through the loops, the seed, to get the extrusion. I believe we got it on some of the. There we go. So it's actually, so this is the one, two, three, fourth extrusion of the x-axis, and we have the extrusion of the z-axis here. So that's what the loop offset does, and it only works for the axis order highest, and it will not work for the lowest, because at lowest, then the y essentially will be looped first and x second. So there will be no chance of actually, there will be the y-axis, which is the lowest in this instance, is 100% extruded in the lowest solver. So loop offsetting the loop, or delaying the extrusion using the loop offset, will only happen in the axis and the highest axis order option. Okay, so we have the threshold, and now we have the influence. So basically what this does is, let's manually extrude this. and extrude this. Okay. So influence. Description is number of linked faces for face verts to have in order to extrude. So by default, so usually you just want to have it at 4. I've included 3 to 1 just for special cases, but usually you just have it at 4. So that means that if the face has a vert or any of its vert goes past the 4 values, the 4 example we have 4 here. That means that this face, any of its verts, one. So the link faces means that this vert has a link faces of 1, 2, 3. So this will be extruded. This will be a candidate for extrusion using the um, influence of 4. However, this, let's go back. So 1, 2, 3, and 4. Actually, just that's a candidate. Let's make a suitable example. There we go. So link faces of this um, face of this face vert is 1, 2, 3, 1, 2, 3, and here 1, 2. But here we have 1, 2, 3, 4, and 5. So that means if we want to extrude this, this is facing the y-axis. If we want to extrude it in the y-axis using the influence of 4, it will not be included in the extrusion, or it will be um, removed from the possibility of extrusion because one of its verts, this in particular, have link faces totaling of 1, 2, 3, 4, 5. So let's try this. Let's just select this, and you can see that it's not extruding unless we increase the influence to 5. Okay. Oh, here. There we go. I have to explain this after this. So you can see that it extruded from that selection, whereas an influence of 4 will not let you extrude that. So the influence is determines if any of the verts or face verts surpasses the number of influence points, then that face will not be extruded. And now we have the source extrude. So remember that our extrusion are the branches, and the source mesh is the stem. Okay, let's just delete this and this as well. So this is our stem, and let's see. By the way, the min and max in the add-on will uh, will reverse its roles. So for example, if max is 0.5 and minimum is 1, then they will reverse their roles, meaning that minimum value is now the maximum value. So don't worry about having the maximum always be the highest. If the maximum goes below the minimum, then the maximum property will become the minimum value in the script. You can also Control C, V to copy the values. Okay. source extrude means that, for example, in the x-axis, means that if I have 2 in the x-axis, it means that it will have a chance of extruding 2 times or selecting a face in the stem or the source mesh 2 times before trying to extrude in the branches or the extruded faces. So for example, in Y, in this setup, 1, you can see that the y-axis, which is this one here, this direction, is not extruding at all in the selected faces in the source mesh because we have 0 here, meaning that it will only extrude from the branches. If we set this to 1, then it will have the ability or the chance to extrude from the source mesh 1 time. So 2 here means that uh, after it expended the a single extrusion from the source mesh, then the second one will of course be extruded only from the branches. So for example, if we have axis loop number of 4 and we set the source extrude to 4, then it will have the possibility of extruding from the stem or the source mesh 4 times. It will still have the possibility of extruding from the branches even if you set the source extrude to 4. This does not monopolize the extrusion on the source mesh, but it only makes it possible to extrude from the stem or the source mesh in that many times, which in this case is 4. And using what we've learned, we can actually do this. This is a random operation, but we can actually do this. Use this to somewhat um, do what we like to do. Base cut will subdivide the selected faces, making the faces smaller. So one subdivision meaning that the original size of the um, faces. More subdivision means smaller faces from the stem or the source mesh, and also more faces to be randomized. And then we have the inner cut. This is the subdivision of the branches. Set this to 0.5 and 1, and set this to 2. Set this to 0. So we have 2 extrusions in the x-axis with randomized height. So this is the first extrusion, and this is the second extrusion, or the second loop. You can see that we've lowered the inner cut to 0. So this doesn't have any subdivision. So the inner cut subdivides the branch. So if we have inner cut of 1, it will have that subdivision. Inner cut of 2, and if we try and use that using the operator, 1, 2, so 2 subdivision in the branches. There we go. And this allows for more faces in the branches for the other axis to extrude upon. So y-axis goes in this direction, F9 to bring back the redo panel. Now, if we increase the inner cut of the x-axis, then the y-axis have more faces to extrude on. Same with the z-axis. Okay, let's now do a controlled, I know this is random, but let's do a controlled extrusion, somewhat controlled extrusion. So we have, remember that this needs faces to be selected in order to extrude upon those faces. And if we only have this face here, then it will only extrude from that face. So this face is currently facing the X axis. So if you're surprised that if you're trying to extrude at the Y axis, it's not extruding, that's because this is literally facing at the X axis. So let's try the X axis. Okay. Uh, two, oh, just one. And four branch subdivision. And we need say we can create sort of, there we go, and increase this. So x-axis threshold is 1. Oh, that's right. Let's try and get it on. There we go. So you can have a bit of control once you know the what the properties do. Okay, but of course this is random. It's all about randomization, and we just want to have fun with the randomization. So let's try and do a quick work with this. Okay, the rest of the properties, I leave it to the documentation. Just read about what they do. It's very simple. And they also have, if you hover over any properties in the or operator in Blender, it will have a short description on what it does. Okay, I'm going to try my save preset, and we have going to try and do just a constant scale, which is 1, and just let the randomization give me what I want. So this is purely concept art. So we need to uh, smaller faces. So increase the base cut, lift seed. Okay, okay, I can live with that. So let me try and use the same operator on the extruded mesh. Control C, V, and V, and V. There's also a redo. There's also a chapter on the redo panel on how to bring it back, how to change the modes, and all that in the documentation. Please read the documentation. I took me a long time to write that. So I'm trying to get some kind of a space station look. Remember that you can limit the extrusion on the selected faces. So in here, I'm just trying to randomize it on every possible angle by selecting all the faces in the mesh. I'm kind of liking this. Yeah, I like this. Let's add a few faces on the stem or the source mesh and try to extrude from that again. So this time I wanna set the x-axis as the lowest loop, so xy, and then the z-axis as the highest loop, and give z-axis a chance to extrude from the stem, and the rest will have no chance of extruding from the stem. Okay. Okay, let's try and use the randomization tools on this random loop extrude. So from the version that you have now, you might see that this is completely different, and this is because this is the what I'm using now will is the 1.4 version, which will be passed on in a few days or uploaded to the store in a few days. I'm just wrapping things up and finalizing things. Even though some of the properties may change, the workflow will still remain the same, even if you watch the older videos. I'm gonna try this and try it again, but using a different solver. This one here. So if the faces of the object or the resolution of an object is too high, and it might be too slow for an operator to operate on that, or the random operator to operate on that, then do a selective application, meaning that you have to select a few faces at a time and then use the random operators in order to speed things up and avoid crashing. So just a really basic setup. Do it again. And we have a first stage detail of some kind of a space station. So in order for this to work, we'd have to break the profile a bit more by adding more adding more details or variables. So this can already be used for render at this distance, or but if you need to render closer, then you'd have to add more variables, of course. So let's try this part. And we have to quantify the faces in order for this subdivision to work in the randomization script. Quad slice, linked faces, and this is quantified. Select the face, use linked flat faces, This can be found in select linked, link flag faces, right click, as assign to favorites, and then when you press Q, it will be here. So when you select the face and then press Q, it will be there, and it will only select the coplanar faces from the selection. So you don't, in my earlier videos, I'm not using that, so I'm using this, so it takes longer. So right now I'm just using this. And then go to object mode and use the random operators. So paneling can also serve, random panels can also serve somewhat of a bit like random extrusion because of the height property. It's too much. And you can use it anytime. You can even use the extrusions on the product of random extrude or any of the operators. So for example, this one here. Oh, I forgot. Face needs to be quads. So you have to quad everything. But let's just try and use it here on this selection using the Z axis. Whoa. Increase the influence to 5. So remember, influence just usually at 4, but you can extend it to 5 or 6. And then add our preset here. Let's try longest. There we go. And we have our rebuild space station. After doing all those objects, select one here, Shift G, type, selects all the mesh type, create a collection, and then grab all those objects and put it in that collection. Rename it Space Station and close the collection, and you'd have a cleaner outliner. Any new extrusion from after the grouping will be created outside the collection. The add-on does not do automatic grouping to avoid confusion on multi-branch grouping, meaning that an object can have 4 collection branches, and any script would have confusing time trying to uh, figure out which collection to put the new object to. So I just figured let the user manually just place it into the collection to avoid confusion. Okay. Shift GT, and then we have random vertex color. I'm not using any saturation, so maximum saturation is 0. I'm only using color values, and this is hard gradient. Let's do soft gradient and manipulate the value seed. Okay, let's just do a basic shading. Let's select this object here, and also selecting objects. If I want to select the original stem, I'll just hover the mouse in this bunch of objects here, press Alt, right click, or what you've set your selection into, right click or left click, and it will show the menu of all the objects underneath the mouse cursor. Now I know that my stem is cube because I have suffixes assigned for all the uh, products of all of the random operator. For example, extrude is random axis extrude, and R extrude is the loop extrusion or random loop extrude. I think they might be wrong. I might have the suffixes wrong, so I'll fix it in the update. But essentially, that's the way you select objects underneath the all these objects here. So if I want to select the original stem, source object right here. So I know that the first iteration of the extrusion is this one because it doesn't have any numbered suffixes. There we go. Okay, select this. Let's do the cube. New input. You have to have node wrangler enabled in the add-ons for you to have this vertex color. Make sure the cube is the active object, and then copy materials to selected. Set the metallic to 1 and roughness to something like that. And then let's make sure that the separation of the objects becomes more evident. Let's try and use AO color mix set to multiply. Um, add AO, use AO, increase to 1, and get some color around there just in case you need to intensify the effect. There we go. Our base is 4. This is a standard setup for procedurally texturing the design. So you can add dirt here. So I'm just gonna append something. And you might not see it in the recording because I want to set it to record the Blender window. So I'm going to add simple dirt. This is in my Patreon, patreons.com/blendergape. This is free, along with 3 other shaders for easily texturing this, and also a blend scene that has a practical example of the application of the shader. So that's using the setup. So this is basically just adding dirt to the model. Outer scale 0.5, inner scale is 2. Softness So that is it, and that's how you use the random axis extrude. It's pretty, it's quite easy once you get to know the properties involved. And this is one I worked with before this video, just randomizing stuff. And another one is this one. This is over gribbling. This is from the over gribbling video, and this is kind of like a really weird drone. So just like any of the random operator, it all depends on the result of the operator of all the random operators depends on the design of your base mesh or the stem. If you have a very basic design, source mesh design, then the output of the randomization will have, of course, be very plain. So go ahead and try to balance resolution and also um, design in the topology or the way the wireframe are arranged. Okay, so I think that most of that will be in the next video. We're going to tackle random loop extrude and all the things that uh, all the do's and don'ts that comes with the operator. Okay, so that's it for this video. I hope you like my uh, I'm using my real voice and this is real time. And if you don't like this format, then just say so and I'll go back to using the robot voice to make the video shorter or something like that. Okay, thank you for watching and you have a nice day.